Hi, in this video I'm going to go through question 2 on the Math 2007 paper. So in this question, they give us this formula for fn, where n is a positive integer and x is any real number. So for the first bit of part 1, they just want us to write down f3 of x. So that just means we need to substitute n is equal to 3 into the formula that they give us. And we see that if we do that, this is what we get. And if we simplify this, so this minus 2 cubed would give us minus 8. So 2 plus minus 2 cubed would be minus 6. 3 plus 3 is 6, and 3 squared is 9. So this is our final result for f3 of x. And then it wants us to find the maximum of f3 of x. So we need to find the maximum of this quadratic here. So you can do this whichever way you like most. I'm going to differentiate. So this is the derivative of f3, and if we set the derivative equal to 0, then we see that the maximum is going to be when x is equal to a half. So if we substitute x equal to a half back into f3, then we'll see that we get minus 6 times a quarter plus 6 times a half plus 9, which is 21/2, or 10.5. So the maximum value of f3 is 10.5. Okay, and now they ask us, for what values of n does fnx have a maximum value? So if we take a look at fnx, so we see what we have here is a quadratic in x, so long as this first coefficient isn't 0. If this first coefficient is 0, then we don't have this x squared term, and so we just have a straight line. And straight lines don't have maximums, so we know that fnx isn't going to have a maximum if it is a straight line. So if this 2 plus minus 2 to the n is equal to 0, then fnx will not have any maximum. And if 2 plus minus 2 to the n is equal to 0, then that means minus 2 to the n must be equal to minus 2, and so n would be 1. So if we want fnx to have a maximum, then we need n not to be 1. So n must be strictly greater than 1 because n is positive. Okay, and if n isn't 1, then this first coefficient won't be 0 and we'll have a quadratic. So fnx will either look like this or like this. And its shape depends on whether this coefficient is positive or negative. So fn will look like this first graph if 2 plus minus 2 to the n is greater than 0, and it'll look like the second one if it's less than 0. And so we see that if we wanted a maximum, then we're going to need fn of x to look like this second graph. And so we're going to need 2 plus minus 2 to the n to be less than 0. And so if we want 2 plus minus 2 to the n to be less than 0, then we're going to need minus 2 to the n to be less than minus 2. And we see that if n were even, then minus 2 to the n, if we raise minus 2 to an even power, then that's going to be greater than or equal to 0 always. And that would be greater than minus 2. So we can't have n being even. But if n were odd, then minus 2 to the n would be negative, and so it would be less than minus 2. So we see that we need n to be odd. So the conditions for fnx to have maximum, we would need n to be greater than 1, and we'd also need n to be odd. Okay, and for part 2, first they just want us to write down f1 of x. So we just need to substitute n equal to 1 into the formula that they gave us for fn of x. So if we do that, we see that what we get is this, and we've got a 2 minus 2, so this x squared term is 0. So we end up with 4x plus 1. Okay, and now they want us to calculate f1 of x and f1 of f1 of f1 of x. So for f1 of x, then we're just substituting f1 of x in place of the x in f1 of x. So we'd have 4 times 4x plus 1, and that simplifies to 16x plus 5. And now if we do f1 of f1 of f1 of x, then we can put f1 of f1 of x into f1 of x. So we'd get 4 times 16x plus 5 from the f1 of x plus 1. And that simplifies to 64x plus 21. Okay, and now we want to find an expression for this where we're applying f1 k times, and we want to simplify it as much as possible. So let's look at what happened when we applied it twice and 3 times here, see if we can work out a pattern. So for f1 of x, then we multiplied f1 of x by 4, so we have 4 squared in front of the x now, and we also have 4 times 1, and then plus another 1. So what we have is 4 squared x plus 4 plus 1. And now for f1 of x, then we multiplied f1 of x by 4, so all of the powers of 4 here are raised by 1 now. And then we added the 1 on the end. So we get 4 cubed x plus 4 squared plus 4 plus 1. And so we see we do get a pattern. So the number of times that we apply the f1 is the power that the 4 in front of the x is raised to. And then we're adding on decreasing powers of 4. And so if we had applied f1 k times, then our formula would look like this. And they wanted this to be simplified as much as possible, so we see that we have a geometric series added on the end here, and so we can use the formula for the sum of the geometric series to simplify this. So here our first term is going to be 1, so a is 1, and we're multiplying by 4 each time, so the r is 4, and we have k terms here, so n is k. So if we substitute these into the formula, then we get that this sum here is equal to 4 to the k minus 1 divided by 4 minus 1, and that simplifies to 4 to the k x plus 4 to the k minus 1 divided by 3. Okay, and for the first part of part 3, they just want us to write down f2 of x. So we're substituting n equal to 2 into the formula. So when we do, we get 2 plus minus 2 squared is 4. So that gives us 6 in front of the x squared. And 2 plus 3x is 5x plus 4. And then they tell us that this here is a polynomial. And they want to know the degree of this polynomial. So each time we apply f2, then we're going to be substituting into this equation here. So let's have a look at f2 of x to get an idea of what's going on. So if we look at the degree of this, then we're substituting f2 of x into this equation. And I've only written the highest order term down because we're looking at the degree, so we only need to know what the highest power of x is. And if we looked at this, we can see that the highest power of x is going to come from this x squared term when we square it. So the highest order of x would be x to the 4, and so the degree of this would be x to the 4. And then if we did f2 of x, so if we apply it 3 times, then we're substituting this into this equation for f2. And again, we see that the highest power of x is going to come from this term here when we square it. So the highest power of x we get is x to the 8, and so the degree of this would be 8. And so we see that f2 has degree 2, and then when we apply f2 again, the degree doubles, and when we apply f2 again, then the degree doubles again. So each time we apply f2, we're doubling the degree, because the degree comes from when we square the highest power, and so that's going to double the power. And so if we're applying f2 k times, then we're going to need to double the degree k times, and so the degree is just going to be 2 to the power of k.